Hello. So this is lesson 8.3, which is the geometric sequences and series. So first, we're going to define geometric sequence, and that is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. So the amount by which we multiply each time is called the common ratio of the sequence. Okay, so let's look at an example here. Write the first terms of a geometric sequence with first term being 12 and the common ratio is a half. Common ratio is written as R. So our first term, we know that that's 12. Well, the second term is going to be half times our first term because our common ratio is a half. So half times 12, which is 6. Our third term is going to be half times the second term. So half times 6 is 3. Fourth term is going to be half times the third term. So half times 3, and that's 3 over 2. Okay, we need first 6 terms. Oops. Um, so our fifth term is half times the fourth term, which is half times 3 over 2. That when we multiply fractions, it's top times top and bottom times bottom. So 3 over 4. Sixth term is half times the fifth term. So half times 3/4, again, top times top and bottom times bottom, 3/8. So the first 6 terms are 12, 6, 3, 3 over 2, 3/4, and 3/8. Okay, next we're going to look at the general term of a geometric sequence. So the nth term or the general term of a geometric sequence with first term a sub 1 and common ratio r is this. So now next we're going to use that formula for the general term of a geometric sequence. So seventh term, n equals 7. First term is 5, and common ratio is -3. So we're using the formula for the nth term here. So seventh term, first term is 5, common ratio is -3, and it's going to be to the power of 7 minus 1. So 5 times -3 to the power of 6, which when you plug in the calculator, we get 3,645. Okay, next, it's going to be the sum of the first n terms of a geometric sequence. So the sum Sn of the first n terms of a geometric sequence is given by this, in which A1 is the first term and R is the common ratio. Notice that R cannot be 1 because then we would end up with dividing by a 0, 1 minus 1. Okay, let's find the sum of the first 9 terms of the geometric sequence 2, -6, 18, and -54. So n is 9. Our first term is 2. We need the common ratio. So we're going to take the first and see 2 terms and see what happens. So -6 divided by 2 is a -3. Well, let's check. 18 divided by -6 is a -3 as well. And if we check -54 divided by 18, that's a -3 also. Okay, so our sum is the first term times 1 minus the common ratio to the power of n divided by 1 minus the common ratio. So our sum of the first 9 terms, our first term is 2. 1 minus our common ratio is -3 to the power of 9 divided by 1 minus 9. No, that's the common ratio. -3. Um, Now, when we plug it in the calculator, we get 9,842. Just make sure that you're using the parentheses. So -3 to the power of 9 is going to be -19,683 if you want to do it one step at a time. Okay, where do we use these? Value of annuity. So interest compounded in times per year. So P is the deposit made at the end of each compounding period for an annuity at R% annual interest compound. So P is the deposit. Oops. R is the annual interest. N is times per year. T is years. And A is the annuity. And here's the formula. Okay, so let's look at an example. At age 30, to save for retirement, you decide to deposit $100 at the end of each month into an IRA that pays 9.5% compounded monthly. How much will you have from the IRA when you retire at age 65? Find the amount earned on your investment. So what do we know? We know that our P is going to be $100. R is 9.5%, so divided that by 100 is 0.095. N compounded monthly means that there's going to be 12 months in a year, and time is going to be 65 minus 30. So that is 35. Okay, we're going to go ahead and plug this in the formula here. So A equals 100 brackets 1 plus 0.095 divided by 12 to the power of 12 times 35 minus 1 and a bracket closed divided by 0.095 divided by 12. Okay, now when we do the top, we get 2,643.74. And on the bottom, when we do the division, we get 0.00792. And that rounds to 333,805.56. Where are my? There we go. Now, hold on a second. There's a question mark right here. Let me plug it in the calculator and see. Actually, so 100 parentheses open, another set of parentheses open, 17. No, it's 1 plus. I can't read my own writing. Sorry about that. 1 plus 0.095 divided by 12, parentheses closed, to the power of 12 times 35 in the exponent. Then we have to take that down, minus 1, parentheses closed. Yeah, we get this right here. And then 0.095 divided by 12 is 0.0972. Now, here's the thing though. If um, you don't round, um, and do the whole thing um, on the calculator. Sorry, I erased it. I just want to double check something before I say anything because I feel like 12 times 35. And then take that down, minus 1, in close parentheses, divided by, and then parentheses 0.095 divided by 12, parentheses closed, and hit enter. Yeah. So so these are all rounded values right here. So um, the actual value is going to be 333,946.30. So you can see that this is that there is a difference between the um, rounded and the actual value. So what we just calculated, this is what IRA has when you retire. So that is the value. Now, how much did you earn? That would be that value, $333,946.30, subtracted by you're putting in $100 12 times a year for 35 years. So during those 35 years, you do get $291,946 of interest. So that is the amount you earn when you put in $100 every month. Okay, next we're going to look at the sum of an infinite geometric series. So if -1 is less than r is less than 1, then the sum of the infinite geometric series looks like this, in which a1 is the first term, r is the common ratio, and the sum is given by this formula. Again, the absolute value of the r is greater than or equal to 1. The infinite series does not have a sum, so the absolute value of r has to be less than 1. Okay, let's look at this series right here. Our first, so we're looking at trying to find the sum. So our first term is 3. We have to figure out our common ratio. So we're going to take the second and divide that by the first. So 2/3. Now we need to double check. 2/3 is between -1 and 1. It is less than 1 and it is greater than -1. Now we want to double check with these two as well. So we're going to do 4/3 divided by 2. Remember when we are dividing, we're flipping the divisor. So 2 over 1, we're dividing it to a half and multiplying. So hold on, what am I? This should be a 3 and not a 2. I was like, something's not right. So 2 divided by 2 is 1. 4 divided by 2 is 2, and we get 2/3 as well. So it is the r. Okay, so let's calculate the sum. It is the first term 3 divided by 1 minus 2/3. So we get 3 divided by 1/3. Again, we're multiplying, so we are flipping it over. and we get 9 as the sum. Okay, that's it for this lesson. Let me know if you've got any questions. Bye.